All right, let's have a look here at this one. So I had trouble seeing the question. It was a little bit too small, so let's start it fresh now. We have a cubic, and we are told z minus I is a factor of this cubic, and we want to find the other factor, this quadratic factor here. Now we could long divide the cubic by z minus I. Not looking forward to doing that. But if I multiply these terms out, these two brackets out, I should get the cubic. Z by z squared is z cubed. And then z by the az is az squared, so I have an az squared. And let's just continue until I get the other z squared. The next time z squared comes up is when I do the multiplication minus I times z squared. So in total, that will be my z squared piece. And then I'll have the z piece. And then at the very back, the very last term will be minus I times b. Now, if you compare that to what we're supposed to get, which is z cubed, and I'll put the minus inside, minus 10 minus I z squared, and finish up on, and in fact I'll write it bi to make it even more obvious what I'm doing here, minus 29I. I think you can see quite clearly now, by comparison, that the A has to be minus 10, and the B, now that's minus 29I and minus BI, so the B has to be 29 then. Does this quadratic have factors? I suspect not. Yeah, well, I should say it doesn't have real factors. So we'll have to factorize it in order to plot the three solutions. Okie dokie. So our quadratic is z squared minus 10z plus 29 equals 0. So z equals minus b plus or minus the square root of b squared minus 4ac. So that's minus 16 all over 2a. So that would be 10 plus or minus 4i over 2, which would be 5 plus or minus 2i. Let's confirm. Yeah, and yeah. So on the Argand diagram, 1, 2, 3, 4, 5, I, 2i, minus I, minus 2i. So the first point was I. So I better put in a different color. Here's the first point, I. And then 5 plus 2i. And then 5 minus 2i. 5 minus 2i. 5 plus 2i. And then I. I'll just finish by double checking my answer. No, I think it's okay. I think it's okay. All right. That's only part A done. Part B done. We still have to do part C. Okay. Let's look at part C now. Okay, so we have W1 and W2 equals W1 squared, and we have to verify this. Wow. Okay. So I suspect it'll be easier to start with the right-hand side. Let's see what I get if I expand the right-hand side. X minus W1y times x minus W2y So that's x squared minus x w2y plus w1xy plus w1 w2y squared. So I shouldn't be left with any w's. And annoyingly, I don't think I have a w1 squared. It's really a pain. Although, actually, minus xy, oh. Well, you know what I can do? I can factor out here. I can say this is plus, and then this is w1 minus w2 xy plus w1 w2 y squared. So I guess I'm finished if I can show that w1 minus w2 is 1 and w1 times w2 is also 1. But I'm going to have to calculate w1 squared. w1 squared is w1 times w1, which is minus a half plus root 3 over 2i, oh, don't have space to write it out again, squared. So that's a quarter minus root 3 over 2i, and then that's 3 over 4i squared, so that's minus 1. So a quarter minus 3/4 is minus a half minus root 3 over 2i. Okay. So w1 minus w2. Well, I have w2, so that will equal x squared plus w1, which is minus a half plus okay, I have it correct except for the signs, so I've made a sign mistake because I see what's going to happen. It's going to be w1, because the minus a half minus w2. Oh, that's going to be 0. That's kind of bad. Before I continue, I want to make sure that the previous calculation was correct, and then I'll continue. Okay, let's just check now. It's a little bit small on my screen. X minus w1y, x minus w2y. X by x is x squared. That's xy w2. And then that's xy. Oh, that's a minus as well. So I did make a sign mistake there. So they're both minuses then. Okay, that's all right. And then I'm going to assume that's 1 and that's 1. And now I'm going to show that. So see below. Okay, so first let's get w2, which is w1 squared, which will be minus a half plus root 3 over 2i squared, which is a quarter minus root 3 over 2i minus 3 over 4. So that's going to be minus a half minus root 3 over 2i. And then minus w1 minus w2 is a half plus root 3, no, sorry, it's minus w1 plus and minus, so it's minus there. And then minus w2, so that's plus a half plus root 3 over 2i. So that's a half plus a half, which is 1. And then now calculate W1 times W2. So that is, what's W1 again? Minus a half plus root 3 over 2i. Times a half times minus a half minus root 3 over 2i. So that'll be a quarter. And then that's a negative and that's a positive. So they cancel. And then it's the piece at the back. Minus minus makes a plus 3 over 4, which is 1 then. Yeah, so we have to prove the 1 here. So we've shown that that equals 1, and then we have to prove for the other coefficient as well. So that also equals 1. Yeah, this is a very long, tough question because I'm not even finished yet. There's still a final part here. So, so far it looks okay. Right. Express this in polar form. So, positive and negative. So it's over here. Okay, so the or would be the square root of 2 squared and then 2 root 3 squared, which is 12, which is nice because that's 4. And then tan theta would equal minus root 3 over 1, which is minus pi over 3, which looks good because it matches up here. I can check the answer. So the answer is 4 bracket cos minus pi over 3 plus I sine minus pi over 3. 4 cos minus pi over 3 is 2. And then if I change the cos to a sine, I should get minus 2 root 3. And I do. So I've written that in polar form. I'll give it a name. I'll call it Z. And now I need to calculate Z to the power of 3 over 2 using de Morgan's theorem. So if I 3 over 2, isn't it? 3 over 2 and 3 over 2. So de Morgan says that the 4 gets the 3 over 2 and the cos, they get multiplied. So that's minus pi over 3 times 3 over 2. The 3's cancel. Plus I sine minus pi over 3 times 3 over 2. The 3's cancel. That's 8, I think. And then cos of minus 90 is 0, I think. Yeah. And then sine of minus 90 is minus 1, isn't it? Yeah. Minus 1 I. So the answer is 0 minus 8i. I'm just a tiny bit suspicious of the 0 because they said to write the answer like this, which I've done. It's just I wasn't expecting 0 at all. It is 3 over 2, and I did check that the polar form is right, so if there's a mistake it's probably on the last line, but I don't see a mistake, so maybe they're just messing with my head a little bit. I wonder if I can check here. Okay. Just checking if I can. Okay. Okay, I'm going to check something here now. Two minus can't check it. Yeah, I think I'm right. Looks like it is 8i with the minus. Oh! I'm not finished. It says values. I nearly got caught out there. Well, now actually this is where I might gets a little bit messy because it's not quite an equation. It's a calculation. So I would slightly disagree that there should be values here. And this is quite a common misconception. You know, if somebody says calculate the square root of 9, the answer is 3, not plus or minus 3. But if somebody said solve the equation x squared equals 9, then yes, x is plus or minus 3. Now the problem here is they do say values, but this is not an equation. But you can understand what the values are because there's a square root here because of the power half. So you could put the plus or minus in. But I'm very unhappy with this last question. I really just don't like it. Okay, I better stop here.